dudes, Dude the Builder here, and in this episode of Zig in Depth, we're going to be taking a look at how we can make a WebAssembly WASM module using Zig. First of all, I want to give a big thank you to Vladimir Lazarevic. Hope I pronounced that correctly. He made a donation to the Dude the Builder channel, and that really helps out so I can keep on making this type of content. If anybody wants to help out by making a donation, you'll find the link in the description of the video and also on the channel homepage. So Vladimir, thank you very much. In order to make a WASM module in Zig, you basically have to work just like if you were making a library to be used from, for example, from C or any other language that has a C foreign function interface. So basically what we're going to be doing is we're going to be exporting functions from the Zig side. We're going to see the build.zig configuration, so we can then create a shared library. But specifically, that shared library is going to be taking the form of the WASM module itself. And then we're going to see from the JavaScript side how we instantiate that module, and also how we can export from the JavaScript side and import what we exported from Zig. Okay, so let's first take a look at the Zig file. This is our main.zig here. And one important detail that you want to have in mind when we're going to be using Zig with WebAssembly is that there's a dedicated allocator to deal with WebAssembly. WebAssembly modules have a really strict and specific protocol for dealing with memory. And this allocator that's already available in the standard library in stud heap WASM allocator is tailor-made to handle all of those specific details of how the WASM specification requires any type of memory access in a WASM module. This WASM allocator handles all that for you. Okay, so you basically use it like any other allocator, and it'll handle all the details of the WASM specific side of things. Okay, now we're going to be seeing some functions here, which are just basically normal functions in Zig, but we are making them public and we are exporting them, so they can be available in that library that we're going to be making. And this is basically your normal add function here that takes two parameters and it just adds them together. Here we're using the wraparound version of add. So if overflow occurs, it'll just wrap around to the beginning of the range. And as you can see, we're using I32s. You're going to see a lot of use of I32s when we're dealing with WebAssembly, because basically the 32-bit signed integer is the primary data type, numeric data type that we see in WebAssembly. But we will see other data types in a bit. And Zig will handle any type of conversion that has to be done between the Zig side and the WebAssembly side. Okay, so here just a simple little function here that will add its two parameters and return the result. Here we have another one that just does the same thing but subtracts, once again using the wraparound subtraction. Next up is an important function here that we're going to be making use of, and it's basically similar to how we would work within Zig with an allocator. Well, we're exporting here to the JavaScript side an alloc function that takes a length, and this time it's a usize. So from the JavaScript side, we're going to be basically receiving an I32, and Zig will take care of doing the coercion to a usize here. It's basically integer widening here. that will happen automatically. And what we're going to be returning, another thing that we're going to be seeing a lot when we're dealing with Zig and WebAssembly, is the multi-item pointers like this. And that's because anything that has to do with a sequence in memory when it comes to WebAssembly and Zig is basically the same situation that we have when we have interaction with Zig and C. And you have a lot of C code that when you have to deal with a sequence of items in memory, basically like you have a slice in Zig. In C code, you're going to see that there are no slices, but you just send over a pointer and a length. So basically the pointer points to the first item and the length tells you how many items. So in this case, when we're dealing with WebAssembly, you're going to see a lot of multi-item pointers like this. And usually you're going to be also seeing a length parameter somewhere that will tell you how long that sequence is. So in this case, we know the length because we're passing it in. That's what we're requesting to be allocated. And we are going to be receiving on the JavaScript side that pointer to the first item, which is basically a byte, a U8. And this is optional because in the case of an allocation failure, what we're going to be doing here is we're going to be seeing if indeed we're using here the error union modality of the if. And if we do obtain a slice, which means that we were able to allocate that amount of memory, we return that specifically from the slice the pointer field, which is of type multi-item pointer. And if we weren't able to allocate, which basically the error would be out of memory, we're just going to be returning null. Okay. And next up, we're going to see here the counterpart to alloc would be free, because we have to do the manual memory management, both the Zig and the JavaScript side. So from the JavaScript side, if we want to free that memory that we requested previously, we can use this function that we're exporting here. We are requesting the pointer, and once again, you see the multi-item pointer here to U8. Which will basically be the pointer to the first item in the sequence, and the length of that sequence, once again, using the U size, okay? And this time we don't have to return anything because all we're going to be doing is freeing with the WASM allocator, okay? And basically what we do is we use, since free is expecting a slice, then we use the slicing syntax on the multi-item pointer that we have here. And using the length that we pass in, okay? So basically, the convenience that Zig offers with the multi-item pointer, that we can use slicing syntax on that type of pointer, you see how it pays off in this type of example, okay? Next up, we're going to see an example of a function that is basically being exported from Zig to WebAssembly. And it's going to receive, once again, a multi-item pointer and a length. But this time, this multi-item pointer and length combination are basically how we deal with strings, okay? And strings can be a really tricky topic when dealing with WebAssembly, because WebAssembly doesn't have a string type. So we have to basically break it down into the pointer and the length, similar to how we do when we're dealing with C. And in this case, then we're turning around and calling this JSLog function, passing in, once again, the pointer and the length. And that JSLog function here is being imported from the JavaScript side. So to do that, we use the extern keyword. Here we're passing in the name of that object that we're going to be creating in JavaScript, which is, in this case, env. And the function that we will be importing is called JSLog and receives, once again, a multi-item pointer and a length, okay? And with that, we are basically done with the Zig side. Let's see then the build.zig that we need to generate our WASM module. And as you can see, this is a really small, minimal build.zig. What we're going to be doing here is using the add shared library method. We give it a name here. We're going to be using WASM stir. We tell it the root source file, which in this case is main.zig. And this is the different part here in the target. We are specifying the details here by specifying the architecture of the CPU. We're telling it we want this to be a WASM32 type shared library. And the OS tag is freestanding, which basically means that this WASM module is going to be used within a host environment like a browser. There's also the WASI modality that basically makes WASM modules runnable from a shell or operating system perspective with WASM runtime. But in this case, we're not going to be doing that. We're just going to be making a WASM module to be used in the web browser via JavaScript. So we use this OS tag of freestanding. And finally, we specify directly here the release small optimization level, because usually when you're going to be making a WASM module for the web, you're going to want that file to be as small as possible, okay? And then here we have a really important property here of the library, which is called export symbol names. And in here, this is similar to JavaScript modules where you have to specify what you want to export from your module. Well, in this case, here is where we specify the identifiers of what we want to export from our WASM module. If you don't include anything that you don't include in this list will not be exported and will not be available from the JavaScript side, okay? That's really important. And finally, we have here our normal install artifact lib, which will create our file and put it in the zigout lib folder, okay? And to generate that, all we have to do is zig build. Okay, and now if we do a list of zigout lib, we are going to see that in effect we have our WASM module here, our wasmstir.wasm, and it's just 1 kilobyte. Okay, so that's a pretty small module here. And with that, let's now take a look at our HTML here. We basically have an index.html file, and it's a really simple file. All we have here in our body are 3 H2 elements, which will basically serve as the output containers for our little test here. And here we have the script, the actual JavaScript code to work with our WASM module. The first thing that we're going to be doing here is we're going to be creating here the identifiers for what we're going to be importing from the WASM module here on the JavaScript side. And as you can see, we have the same names, add, alloc, free, sub, and zlog. We have an additional one called memory, okay? And this one is made available. Basically, this is part of how WebAssembly works. You're going to have this memory identifier available as part of the exports of a module. And this is how you can interact with the memory that's made available via those allocations that we're going to be doing on the zig side, okay? Here we have a function. This is a convenience function called getView. You pass it a pointer and a length. And what it will do, it'll create this uint8 array, basically what's known as a typed array in JavaScript. In this case, the uint8 array is basically creating an array of bytes on the JavaScript side. And what it needs is the memory where you want to create this array, okay? And here we're passing in memory.buffer. This memory object is the WASM memory, and it has a buffer property that basically points to the raw memory. Then we pass in the pointer, which is basically the address within this buffer space where we want to begin our uint8 array, and the length, okay, where that uint8 array is going to span from this starting point of the pointer in buffer to this length, okay? And here we have another convenience function called encode stir. And this is necessary because JavaScript strings are UTF-16 strings. And when we're dealing with strings basically in any other context, we're going to have to convert it. We're going to have to do an encoding to UTF-8, okay? Which is what we use on the zig side, for example. So here we first calculate more or less how much space we're going to need, because UTF-16 usually uses a 1 or 2 bytes, and that's fixed. In the case of UTF-8, it can be variable from 1 to 4 bytes. Okay, so we make this calculation here, basically multiplying the length of the string that we were passed in, multiplying by 2 plus 5. And this calculation is based on a recommendation that's made on the Mozilla Developer Network. Okay, and here we are going to call our alloc function from the zig side. We want to allocate that space that we just calculated here and assign to capacity. And if everything is okay, we're going to be receiving that pointer here. And here now we will create a new text encoder, and we're calling the encode into method because we want to encode that string into our uint8 array view, which we obtain with this convenience getView function that we saw previously. We pass in the pointer of that memory that we just allocated and the length, which would be the capacity here. So we are creating this uint8 array, and with the text encoder, we are encoding our string, which is going to be in UTF-16, to UTF-8 and putting it in this uint8 array view of our memory. Okay, so this is what I said, the tricky part of dealing with strings when you're dealing with WASM is that you have to be encoding and decoding basically anytime that you're going to be crossing that boundary. Okay, and we return here the pointer to our newly encoded bytes. The written here is basically the length of that encoded string, and capacity is the entire memory that we allocated here when we called our alloc function. And we need both the length of the string and the capacity, because when we're going to be working with the string, we need the length, and when we're going to free the memory, we need to free everything, so we need the capacity. Okay. Here, once again, we have another convenience function, and in this case, we receive the pointer and the length, because basically what we're going to be doing is in the reverse direction. Let's say that Zig placed a string in the memory for WASM, and now we have to encode convert it from UTF-8 to UTF-16. So what we're going to be doing here, once again, we create a new text decoder. This time we're going to be decoding instead of encoding. And we want to decode this UTF-8, we'll convert it to UTF-16. Once again, we create a view, a uint8 array, and pass in the pointer to the memory, that location in memory, or WASM memory, where that string is located, and length. Okay, so this is basically coming from the zig side to the JavaScript side, and converting it to UTF-16 from UTF-8. Now here we have that env object that I talked about when we looked at the Zig code, that only function here that we're going to be exporting from the JavaScript side to the Zig side. Here it is. It's called JSLog. It's a property of this env object. And we're using here the fat arrow syntax of function definition in JavaScript. We have two parameters, pointer and the length. And what we're going to be doing is we're going to be calling our convenience function here, passing in that pointer and the length to obtain the string itself. Here, this message here, MSG, would be basically a UTF-16 JavaScript string. And then we can pass that in. We're here going to be printing it in that H2 element with the ID log, using the text content property, so assigning it message. And we're also going to be printing it in the console with console.log. Okay. And finally, we're going to be seeing here the code that you use to basically instantiate a WebAssembly module. Okay, we're going to be using here the WebAssembly object, global object from JavaScript, using here the method instantiate streaming. We're using here the fetch function from JavaScript to basically load in that WASM file. Here we have to fix this name because it's actually wasm_stir.wasm, okay? And we are passing in our import object, which is this object over here that we defined called env, okay? And then once that is finished, we're going to be receiving the WASM binary object. And what we're going to do here, we're going to be using some JavaScript destructuring syntax here, so we can basically extract all of those exported items from the WASM binary here. Okay, using here the WASM binary instance.exports field. Okay, and then once we do that, we can start working with our imported functions. Here, basically, what we're going to be obtaining, the pointer, the length, and the capacity. We're first encoding this string literal that we have here on the JavaScript side. We're including here some Unicode characters here, so we can make sure that we are handling the encoding and decoding correctly. Okay, and then we call that zlog function that we imported from the Zig side, which once again on the Zig side is going to be making use of the JavaScript JS log function. And finally, we free the memory that we allocate. Here we make a call to our free function on the Zig side, which will free the memory using the WASM allocator. We pass in the pointer and the capacity, okay, which is the total memory that we allocated for our string. Okay. And here at the end, we make use, once again, we are going to send the output to these two H2s that we have in our body. And we're going to be basically making use of our two exported functions, add and sub. Okay. And that's basically it for our HTML file. Okay. Now, let's come on over here. Here we have basically the normal structure of a Zig project, but I have this World Wide Web www directory. Let's see what we have in here. Here we have what you would find in a web directory. Here we have an index.html. We have a 5icon.ico, and here I have a symlink. Which once again I have to correct that name. Let's make that correction here. Let's remove that. Let's make the link again. Zig out lib wasm_stir.wasm. Okay. So now we have the correct name of the WASM module, which is wasm_stir.wasm, which basically it's a symlink to our zig out lib WASM module exported. Generated by Zig build. Okay, so what do we have to do? I have a little web server here program that basically just serves in localhost the current directory. Okay, as you can see from the message here, it's going to be serving on port 8080. So let's head on over to the browser and let's navigate to our localhost 8080. And here we go. As you can see, we have here the results from our add and sub calls. With passing in 41 and 1 for add, we get 42. We pass in 43 and 1 for sub, and we get 42. And here we have our correctly encoded and decoded string, okay, with our Unicode characters here, our friendly little Zigwana, and our Zig lightning bolt. So basically we can see, and also here on the console we have the string, okay, that's properly has been handled. So as you can see, we are in effect, let's see here in our network tab, we are loading our WASM here, or wasm_stir.wasm. correctly. Okay, so everything is working as expected. Okay, let's go back to the terminal. So that's basically what I wanted to demonstrate. The process at first may be a little complex for newcomers, but once you have this basic structure of a Zig project that's going to be generating a WebAssembly module, and you have the knowledge of how to deal with encoding and decoding strings in JavaScript, and how to deal with passing those strings by using the pointer and the length, you can basically achieve anything that you want by using the Zig programming language on the low-level side, and JavaScript on the browser, or if you're going to be using WASM for the WebAssembly system interface. Okay, I hope you can make the most of this. Do the builder here. I'll see you in the next one.